Hi everyone. Our project is about neural machine translation from English to Dravidian languages, and our team members are along with me Naresh Bulsetti and Vishnu Chaundur. And this is the agenda. It consists of introduction, objective methodology, discussion about the data set, how the challenges we faced in this project, results and analysis, conclusion, reference. And coming to the introduction part, the introduction discusses how NMT has transformed automated translations by being more accurate and context sensitive than older methods. It also mentions the advancements of machine translation from Dravidian languages, the creation of multilingual models such as MT5, which is a variation of the T5 model, and its application in translating English into other languages like Tamil, Telugu, Kannada, Malayalam. So the focus is on translating for low resource languages and the potential expansion of NMT systems. And coming to the objective, this slide outlines the main goals of paper, focusing on improving bilingual machine translation for languages with fewer resources like those in Dravidian language group, um, or like overcoming the hurdles in machine translation systems caused by scarce resources. And a common issue for languages such as those in Dravidian family, concentrating on translation from English to Dravidian languages like Tamil, Telugu, by creating translation systems specifically designed for these languages, utilizing pre-trained models and fine-tuning them with the data augmentation strategies to enhance the training data, especially for languages that lack substantial monolingual data, implementing BLUE score to assess the precision of the translation models and thus thereby providing the quantifiable evaluation of a translation quality for various languages, various language combinations. And coming to the neural machine translation, uh, this slide provides an overview of NMT, emphasizing its reliance on artificial neural networks for predicting likelihood of a word sequence, hence offering a unified approach to modeling entire sentences. So NMT outperforms older rule-based and statistical methods by delivering translations that are both more fluent and more accurate, capturing subtle linguistic details. However, this enhancement in output quality comes at the cost of requiring significant amounts of data and computational resources for training. So, overall, NMT represents a substantial leap forward in machine translation technology, forming the backbone of many online translation services in use today. And so this slide speaks about the importance of NMT for Dravidian languages. You see this map is India, and these are the most spoken Dravidian languages like Telugu, Tamil, Kannada, Malayalam, Gondi, and this facilitates seamless communication across Dravidian languages, vital for linguistic diversity in South Asia, and ensures linguistic representation in the digital age, providing the access to information and technology in native languages. So these are the some challenges in NMT for low resource languages. Like some languages support homograph words. Like in the example, in the heart attack and dog attack, attack is the homograph word, but it differs by the meaning. Some languages have multiple scripts. Like in Punjabi, there Punjabi, if it's the same language, but it is divided into two subgroups like Gurumukhi and Shamukhi, and grammatical variations between languages lead to ambiguity. So judging of speaker's intention is different meanings of sentences of words vary with the speaker's intention, like metaphor, sarcasm, like that. And these are the challenges in MT. And this is of the data set. In Telugu we have a number of rows, nearly 50,000, and for Tamil also 52,000. Both together we have 1 lakh pair of rows. So you can see this is the data set. Like it will have a English sentence and the Telugu translated sentence in the same way. For the Tamil too, these are some pairs of sentences. You can see this is the source and this is the target. This is how the data set looks like. And the proposed methodology here, my friend Vishnu Chaundur will take on. Thank you.
Hello all, this is Naresh Bulshetty and this is our project Neural Machine Translation from English to Dravidian languages. When coming to the slide, methodology, the initial setup involves installing crucial Python libraries like transformers and datasets essential for machine translation tasks. Data loading ensures alignment of English Tamil parallel text for accurate translation paths. So, leveraging Hugging Faces Transformers library, the MT5 model and tokenizers are initialized, setting the stage for text processing. If a GPU is available, the script configures the model to utilize it, optimizing training speed and efficiency through parallel computation. This comprehensive environment setup enables seamless handling of language data and ensures the model's readiness for translation tasks. So from installation to hardware configuration, each step contributes to robust framework for training and inference, fostering efficient utilization of resources and enhancing the overall performance in machine translation endeavors. And coming to the next slide, the next phase of machine translation involves data encoding, preparation, and model training. Text in English and Tamil are tokenized using the MT5 tokenizer and converted into sensors, ensuring adherence to set maximum sequence length here. So the tokenized data is then grouped into batches, aiding in efficient learning and memory management during training. For model training, an ADAM, W optimizer, and learning rate scheduler are set up to efficiently update model weights. Through multiple epochs, the model learns English to Tamil translation by processing data batches, calculating loss, and adjusting parameters to minimize it. Training progress is tracked by monitoring the training loss and while periodic evaluations on a validation set ensure the model generalizes well to new data, affirming its translation capabilities. So these steps establish a systematic approach to training the MT5 model, optimizing its performance for accurate transition task. And then coming to the next slide, number 5 from the methodology. Uh, In the final stages of machine translation, the process focus on management, evaluation, and visualization. After training, the model tech and tokenizers are saved to disk, ensuring their reusability without retraining. The script also facilitates reloading these saved components for further user evaluation. So, evaluation of translation quality employs the BLEU score, the standard metric comparing model generated text to reference translations. Additionally, the script demonstrates translation capabilities by inputting English sentences and displaying corresponding Tamil translations. And visualizing the training loss over time provides insight into the model's performance improvement during training. So collectively, these steps ensures efficient management of trained models through evaluation of translation, quality, and insightful visualization of training progress, and culminating in a comprehensive understanding and assessment of the MT5 model's translation capabilities. And then coming to the next slide, introduction to MT5. It's from the pre-trained models. MT5, an extension of Google Research T5 model, is a multilingual powerhouse designed for diverse language tasks. It is developed to understand and generate text in over 100 languages. MT5 expands T5's capabilities globally. Its architecture, rooted in the transformer model framework, employs an encoder-decoder structure. Modifications from T5 enhance MT5's multilingual support, enabling seamless language processing across various contexts. The encoder handles input text while the decoder generates the corresponding output, facilitating versatile language transfer across task languages. With its robust architecture and extensive language coverage, MT5 stands at the forefront of multilingual natural language processing. It caters to diverse linguistic needs, offering a powerful solution for global applications in translation, text generation, and also in the other language related tasks. And then coming to the next slide, we have the pre-trained model here. So the study of T5 conducted within the unified text-to-text framework enables a diverse language understanding task to be analyzed comprehensively. T5 maintains the transformer architecture but incorporates modifications such as layer norm application, position embedding schemes, and extensive dropout for enhanced performance. Pre-training on the colossal clean crawled corpus C4 provides a robust foundation crucial for the success of language understanding models. The experimental setup involves pre-training on C4, followed by fine-tuning for specific downstream tasks, and also with adjustable variables, including transform architecture, pre-training setup, fine-tuning setup, and model size. So, by systematically exploring these variables, T5 establishes best practices for transfer learning in natural language processing by streamlining model development into an effective pipeline for creating proficient language understanding models. And coming to the next slide, here we have in our project, we utilized the MT5 small model and downloaded the corresponding tokenizer specifically tailored for the MT5 small variant. This choice allowed us to optimize resource usage while still benefiting from the capabilities of the MT5 architecture. By selecting the small model variant, we aim to strike a balance between model size and performance by ensuring efficient execution while achieving satisfactory translation results. Additionally, downloading the tokenizer tailored for the MT5 small model ensured compatibility and seamless integration with our project's requirement. Overall, leveraging the MT5 small model and its associated tokenizer enabled us to efficiently handle translation tasks within our project's scope. And coming to the 17th slide, here we have the attributes and the differences between the text-to-text transformer and the multilingual text-to-text transfer transformer. So the comparison between T5 and MT5 in a short way. So T5 primarily supports English with potential adaptation to other languages, relying on the C4 dataset. In contrast, MT5 inherently supports over 100 languages, leveraging the multilingual MC4 dataset. While T5 is versatile within English tasks, MT5 offers high flexibility across multiple languages, requiring minimal retraining. So T5 is commonly used for English-centric applications like summarization and question answering. And coming to MT5, it excels in multilingual tasks such as translation and summarization across languages. So both the models come in various sizes tailored to computational needs, with MT5 potentially requiring higher resources due to multilingual processing. So T5 finds its place in English-centric environments and academic research, while MT5 is ideal for global applications, multilingual environments, and business operating internationally. So this is as of now, this is for me, and I'm gonna give it to my the teammate Vishnu. He will continue from now on. Thank you.
So my name is Vishnu Chundur. I'm going to implement the complete methodology of our project. So the project we are using the pre-trained model and the fine-tuning. So normally we can do the machine learning translation, neural machine learning translation using the RNN, LSTM. So it is a regular model. So we are going to deal with some pre-trained model and the fine-tuning in order to boost some models so that we can get the more accuracy and the better. So in our methodology, we are going to set up the environment, and it consists of the Python libraries, and then we are going to load the data sets with the. So we load the English and Tamil in one set, and English and Telugu on the other set. So our agenda is to translate the from English to the South Indian language or Dravidian language. Especially, we are going to take Telugu and the Tamil in this project. So we are going to deal with the MT5 models, which is developed by the Google. And for this order to run this model, we need the CUDA and the GPU module. So here we are going to encoding and the data pre-processing is be taken. So now normally we are taking the two separate data sets. So in order to link the data sets, we are using the pre-processing technique, that is mapping. So then we are going to divide it into the batches. Then we are going to train the pre-trained model and then fine tuning. So then finally, it takes some more time to train the model. So we are saving the model in the Google Drive, and we are going to evaluate by the blue score, and we are going to visualize the losses. How? So this is all the pre-trained model has been completed, my friend. So normally, what is the difference why we are using the MT5 model when compared to the T5 model? T5 model is particularly used for the English translation, and the MT5 is used for the multiple languages, because MT5 model is trained on the 100 different languages. In this, Telugu, Tamil also one of the part of it. So the fine tuning. So we have used the pre-trained model. So in order to fine tuning, we have written the fine tuning code. We are going to train with the Samant Anthar data set we have taken in this project. So fine tuning is code so that we're going to adjust the hyperparameters and the learning rates so that it's going to improve or enhance the performance of the model. So this is the fine tuning code. After we go into fine tuning, we get the losses. So at the initial time, we have taken the 3 epochs, and later we are going to plan with the 10 epochs in order to boost the models. So these are the hyperparameters that we have used. The model selection is the Google MT5 small model, and we are going to use the cost entropy losses in this while the training the model. And the additional parameters, we are going to get 10, and the maximum length is 20. And in the optimizer, we are going to use the Adam W, and we're using the get linear schedule with the warm-up. So for this, in order to run this model, CUDA is important. That is, we are using Lambda. So in order to run this, we are using the Google Pro Collapse. And then now initially we have taken the number of epochs as 3. So now we are going to So initially we are going to take with the 3, then we are going to train with the 10. So in order to do this project, we need the Google Colab Pro version, and we are going to use the GPU T4 model, or we can use a LPU G4 model. LPU G4 is mostly suitable for the 32-bit, and the D4 GPU is used for the 64 bits. In order to process more faster, we can use the L4 GPU module. And for the data set, so I can't connect the my original, my PC with this Google Colab, RAM with this one. So I have used a Google Drive and have loaded my data set in the Google Drive and I have connect the Google Drive to the Colab so that I can import the data from the Colab. After training the model, after pre-training and fine-tuning, so when we look for the English and the Telugu losses, so we can see the losses is approximately from 24, and it's going to, so for the 3 epochs, so, and the Tamil has the more losses when compared to the Telugu, and this is the losses. So in the results, we can see that when we run with this 3 epochs with the 3, so we got like this is the original text, and this is the expected output need to come with it, but the expected outcome is this one. So when we score the blue score, it's got 36, that means 0.36, which is absolutely good. So when I use the test data set, and this is the other example. So when I used my name is as a Vishnu Chundu, but in the Tamil it is not the exact replica of the Vishnu Chundu. It is Vishnu Sansur Yennodia pair, but actually it has to come and pair Vishnu Sundu. In Telugu, it's performing the better. So when I use the, but actually this is not exact because the data set has some not properly exact replica of this. So there are a lot of mistakes in there so that the model accuracy is low. So I mean model blue score is very less. So when I give my name is Vishnu, it's appear Vishnu Chundu. So when I search in the Google, it's also same. So the model is performing better, but the blue score is less because of the training data, because the training data is not good. Same thing is happened with the Tamil also. So finally, I'm going to conclude this project because the project we have explored with only two South Indian languages, Tamil and Telugu. Why I have focused is Telugu and Tamil because they are the native languages. So, and Telugu is a native language and the Tamil, so it is somewhat one of the oldest languages in India. That is the reason I have chosen, that has the reason we have chosen these two languages in our project. So other two languages like Malayalam and Kannada, they are the derivatives of this Tamil and Telugu, so we didn't focus much. So if you're going to run this, so we can do the better results. So the blue score for this is 0.36, that means 36%, and the blue score for the Telugu is 31. But Telugu is, in spite of blue score is less, but producing the better translation when compared to the Tamil, because there are a lot of drawbacks in Tamil because of the Tamil has each when we the model complexity of model understanding of the Tamil language is very complex. The model cannot understand the Tamil complex structure because uh, some words have the multiple meaning which can be seen in other languages, but in Tamil, when you do the stemming and the lemmatization, the root word will change the entire meaning. It has multiple, so it's very complicated model to understand. So on this, we can conclude that the Telugu is performing the irrespective of the blue score. So these are the differences. Thank you.